If you look at the vast fields of livestock we raise to feed humanity, you will find something missing. There are no fields of wolves, no farms of lions, and no industrial pastures of tigers. We have successfully domesticated and bred millions of cows, sheep, and pigs, but we have never once tried to farm the apex predators of the world for food. It is easy to assume this is a matter of safety or fear or some ancient cultural taboo, but the real reason is far colder and completely inescapable. It is written into the fundamental physics of our planet. If we tried to raise lions the way we raise cattle, we would bankrupt our land, deplete our resources, and trigger an immediate ecological collapse, all because of a single, merciless mathematical law that governs every living thing on Earth. To understand why, we have to look past the teeth and claws of these creatures and examine the invisible currency that runs the natural world: energy. Every ecosystem is essentially an energy transport system, starting with the sun. Green plants are the primary engines of this system, capturing solar radiation and converting it into chemical energy through photosynthesis. When a herbivore, like a cow or a gazelle, eats those plants, it absorbs that chemical energy. But here is where the physics of life exacts a massive, non-negotiable tax. A cow does not simply store every calorie of grass it consumes, it has to live. It burns energy to keep its heart beating, to pump blood, to digest its food, to migrate across pastures, and to maintain its body temperature. In the language of thermodynamics, most of that energy is lost as heat. In fact, across almost every ecosystem on Earth, roughly 90% of the available energy is lost at each step up the food chain. Only about 10% of the energy from one level actually makes it into the physical tissue of the animal at the next level up. This is the 10% rule, and it is one of the most fundamental, unyielding laws of ecology. The math of this rule creates a strict, pyramid-shaped hierarchy where every step upward represents a massive contraction of available life. If you start with 1,000 kilograms of grass in a wild field, the thermodynamic math dictates that you can only support about 100 kilograms of herbivores, like gazelles or rabbits, who graze upon that grass. And when you move to the next level, the carnivores who hunt those herbivores, the tax is applied once again. That 100 kilograms of herbivore tissue can only support a mere 10 kilograms of a predator like a lion or a wolf. This simple equation explains why the wild is not overflowing with predators. Apex predators are rare not because they are bad at hunting, but because they are thermodynamically expensive to maintain. There simply isn't enough energy flowing through any given ecosystem to support large, dense populations of animals sitting at the very top of the food chain. Compare this to the animals humans rely on for food. A cow is an exceptionally efficient vehicle for human nutrition because it sits just one trophic step removed from the sun. It converts grass directly into meat, allowing us to raise them by the millions because the energy math of the land can easily support that direct relationship. But if we wanted to raise lions for food at the same scale, we would first have to raise millions of gazelles to feed them, which in turn would require growing billions of tons of plants. The land required to support such a multi-tiered farming operation would be almost incomprehensibly large, rendering predator farming a physical and economic impossibility. Even when humans do manage to raise predatory or predator-adjacent species, we are only able to do so by exploiting massive external loops. Take salmon farming, for example. Salmon are active predators, and keeping them in ocean pens requires feeding them vast quantities of wild-caught fish meal. We are essentially vacuuming up thousands of tons of smaller fish from the lower levels of the marine food chain just to produce a fraction of that weight in high-end salmon meat. It is a process that operates at a massive thermodynamic deficit, hidden only by the sheer scale of modern industrial shipping and fishing networks. On land, without the ocean's vast wild reserves to harvest for feed, trying to run a similar operation for land carnivores would collapse under its own weight almost immediately. But the 10% rule is not just a limitation. It is a vital safeguard that keeps our planet from descending into chaos. Predators are structurally essential to the ecosystems underneath them because they act as regulators. They do not just consume prey, they dictate how that prey behaves and interacts with the landscape. When we look at what happens when apex predators are removed, we see the true value of their scarcity. When gray wolves were wiped out from Yellowstone National Park in the 20th century, the elk populations boomed unchecked. Without the constant threat of predation, the elk altered their behavior, staying in one place and overgrazing the delicate vegetation along the riverbanks. This caused massive erosion, degraded the water quality, and destabilized the entire local food web, affecting everything from songbirds to beavers. When those 14 wolves were reintroduced in 1995, their presence sent a trophic cascade throughout the park. The elk moved again, the willow and aspen trees recovered, the riverbanks stabilized, and the physical geography of the rivers themselves began to heal. The wolf did not accomplish this by being common. It accomplished it by occupying its rightful, highly concentrated place at the very tip of the pyramid. Apex predators hold entire food webs together simply by existing near the top, acting as the structural keystone that prevents the lower levels from expanding and stripping the habitat bare. They are the regulators of life, and their scarcity is a mathematically enforced necessity. Throughout history, humans have often viewed the wild as something to be conquered, tamed, or converted entirely into resources for our own consumption. We have successfully bypassed many of nature's constraints through technology, agriculture, and industrialization. We have filled the planet with millions of herbivores, turning vast forests into pastures to feed our growing populations. But we cannot escape the ultimate ledger of the biosphere. Every time we push an ecosystem to its limits, removing the predators that keep it stable or overexploiting the lower trophic levels, we run headfirst into the same thermodynamic reality that has governed life for billions of years. Nature decided long before we did that there was only ever going to be one of the hunter for every 100,000 of the hunted. It is a law that cannot be negotiated, a tax that cannot be avoided, and a mathematical truth that ensures the wild remains wild, balanced on a knife edge of beautiful, calculated starvation.